So hello everyone. So in this video I am going to concentrate on previous year questions on potential and capacitors chapter. Okay. See the first question. A parallel plate capacitor is charged and then isolated. Okay. So the effect of increasing the plate separation on the charge, potential and capacitance respectively are. Okay. So what they are saying here they have given a parallel plate capacitor and it is charged. Okay. How will you charge? So it can be charged by connected to the potential source. Okay. So it is get charged. Okay. So what they are saying, after that it is isolated. After this it is kept apart. It is isolated. There is no external potential is applied. Okay. So obviously after the isolation Q is constant. Okay. Charge is constant. The effect of increasing the plate separation. So here they are increasing the plate separation. Here this plate separation they are increasing now. Okay. So then what happens to the potential and capacitance? Okay. See, we can relate the potential and capacitance. First I will calculate the capacitance. See, capacitance of the parallel plate capacitor is given by the formula C is equal to A epsilon naught divided by D. Okay. So here the separation, what they are doing, the separation is they are increasing. So it is inversely proportional to the C. So that's why C will decreases. Okay. So next one, C is decreases. Okay. And so we know that formula C is equal to Q by V. Capacitance of the capacitor is given by the ratio of the charge on the capacitor to the potential difference. Okay. So I want V. See, V becomes Q divided by C. Okay. So both are same only. See here, V is inversely proportional to the capacitance. Okay. So here this capacitance is decreasing. That's why potential will increase. Okay. So that's why V is increases. Okay. So the option is, so no, first one, charge is constant and potential. So potential is increases. So potential is increases and the capacitance is decreases. Okay. So option B is correct. Okay. So see the next question. A spherical shell of radius 10 centimeter is carrying a charge Q. If the electric potential at the distances 5 centimeter, 10 centimeter and 15 centimeter from the center of the spherical shell is V1, V2 and V3 respectively, then, okay. So what they are given, they have given a spherical shell. They have given a spherical shell having the radius, so radius is 10 centimeter. Okay. So and it is carrying a charge Q. If the electric potential at the distances, so they have given a 5 centimeter, 10 centimeter and 15 centimeter. Okay. So 10 centimeter means it is, so less than, you see it is inside only. This one is 5 centimeter, this is 10 centimeter and this is 15 centimeter. Okay. So now from this options, so I can mark it as V1 and this as V2 and this as V3. Okay. By seeing the figure only you can conclude that V1 is equal to the V2. Why? Because it is equipotential surfaces. See, equipotential surfaces is the surfaces in which the potential remains same at all the points. Okay, at all the points also in inside also. So the potential remains same. Okay, so that I can conclude that V1 is equal to V2. Okay, so here potential is more and at this point also the potential remains same. Okay, so as a later on if you move to the distances, the potential is decreases. Okay, so the potential is decreases but this value is greater, so that's why V1 is equal to V2 which is greater than V3. Okay, so don't get confusion between this option and this option. So the potential is decreases but this value is greater than V3. Okay, so that's why, so option D is the right answer. Okay. So next numerical is nature of equipotential surface for a point charge is. Okay. See, for the point charge, suppose if I consider this as a point charges, so around the point charges we will get a equipotential surfaces. Okay. So this is a representation of point charges. Okay. So now which is the option is correct? So ellipsoid with the circle of the foci, this is wrong. Sphere with a charge at the center of the sphere. Okay, so it is correct only. Sphere with a charge at center of the sphere. Okay, so the answer B is right answer. Okay, so see the next numerical. A particle of mass 1 gram and 1 microcoulomb is held at the rest on the frictionless horizontal surface at the distance 1 meter from the fixed charge 2 millicoulomb. If the particle is released, it will be repelled. The speed of the particle when it is at the distance of, okay. So here what they are saying, here they have given a particle, okay, a particle of mass 1 gram and 1 microcoulomb, okay, is held on the frictionless horizontal surface at the distance. So it has they given the distance. So the distance is 1 meter, okay, from the fixed charge 2 millicoulomb, okay. If the particle is released, it will be repelled. Why it will be repelled? Because both are like charges only. Like charges will repel each other, okay. It will repel each other, okay. And the speed of the particle when it is at the distance of, it will move to the new distance. So that new distance is 10 meter, okay, from the fixed charge. So we need to calculate. So the speed. So speed is nothing but a velocity. V is equal to question mark. We need to calculate the velocity, okay. See, from energy conservation principle, we know that EI is equal to EF. What is the meaning of EI is equal to EF? Means energy before initial energy is equal to the final energy, okay. So this is the energy conservation. So this energy conservation, so in terms of potential is given by the formula. So initially we have the potential 1 by 4 pi epsilon. Here we have the two charges Q1, Q2 divided by Ri, okay. Ri means the initial position, okay. So this is for energy initial, and energy final is 1 by 4 pi epsilon naught Q1, Q2 divided by Rf, okay. This is the distance R at final position, plus I will write half mv square, okay. Why? Because it is moving. So it is moving means obviously there is kinetic energy. This kinetic energy is given by the formula of mv square, okay. See now, here it will become of mv square is equal to, here from the both the terms 1 by 4 pi epsilon naught Q1 Q2 is common, remaining is 1 divided by Ri minus 1 divided by Rf, okay. So now on simplification, what you will get, first I will simplify these terms. So that is equal to, what is 1 by 4 pi epsilon naught value? 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 into Q1. So what is Q1? Q1 value 1 microcoulomb, okay. 1 into micro means 10 to the power of minus 6 into Q2. Q2 value is 2 millicoulomb. 2 into milli means 10 to the power of minus 3 coulomb. 1 divided by Ri. Ri is the initial position. That is 1 minus 1 divided by Rf. Final position is 10 meter, okay. So final position is 10 meter, okay. See now on simplification, here 9 1s are 9, 9 2s are 18, okay. So this is 18, here 10 power 9, so 6 plus 3 9, minus 9 and plus 9 it will get cancelled, okay. 9 2s are 18 into, so if you take it LCM, so here 10, so 10 1s are 10 minus 1 1s are 1, okay. So we'll get 9 divided by 10, okay. So finally we'll get 18 into 9 divided by 10, okay. But we need to calculate V. So what it will become? Half m V square is equal to 18 into 9 divided by 10, okay. So here I want V square, so I will send this off and m to the right hand side. So what it will become? V square is equal to 18 into 9 divided by 10 into 2 into 1 divided by m, okay. So numerator becomes denominator and denominator becomes numerator, okay. See now on substitution we will get 18 into 9 divided by 10 into 2 into 1 divided by, what is m value? So the mass value they have given 1 gram, okay. 1 gram in terms of kg becomes 10 power minus 3, okay. So see now, so now simplify this one. So what it will become? 18 2s are 36 into 9 divided by, here 10 power minus 3 into 10 to the power of 1. Okay, what you will get? 10 to the power of minus 2. So in the denominator 10 to the power of minus 2. If this minus 2 goes to the numerator, it will become 36 into 9 into 100. Okay, so here, so 36 into, so 100 in 9, 100 is 900. Okay, so v square value we got 36 into 900, but we need to calculate v. So v becomes square root of 36 into 900. So that is equal to, so what is the root 36 value? So root 36 value is 6 into, so what is root 30? So sorry, root 900 is 30. Okay, so finally we will get 6 3 is 18, that is 180 meter per second. Okay, so the answer is 180 meter per second. Okay, so see now, next numerical is 4 metal plates are arranged, so as shown in the figure. So between, so we need to calculate the capacitance between x and y. Okay, so we need to calculate the x and y. So here they have given, let A is the area of the each plates and D is the distance between the each plate. Okay, see, so it's this figure, this circuit looks like a complicated figure, but actually it is very simple only. Okay, so I will do some slight modification. See here, between 1 and 2 we have one capacitor, right? So between 1 and 2 we have one capacitor. Okay, see here, 2 and 4 are at common potential. 2 and 4 are at common potential. Okay, so that's why I will connect it in the form of like this. So here 2 and 4 are common potential. Okay, so now in between 2 and 3 we have one capacitor. Okay, so in between 2 and 3 we have one capacitor, and between 3 and 4, so between 3 and 4 we have one capacitor. Okay, and it is the point y. Okay, and this is the point x. See now the circuit becomes very simple. Okay, so here if you observe the figure here, see here, two capacitors are in parallel. So these capacitors, say I have considered this as C and this one is C and this is also C. Okay, for all the capacitors, capacitance value is same only. Okay, so now capacitors in series, we know that Cp is equal to C1 plus C2. Okay, so here for both the capacitors we have taken as 2 and C only, so it will become 2C. Okay, so here another one capacitors. Okay, so now the circuit becomes one capacitor, this is the point x. Okay, so between 1 and 2 we have one capacitor and we have one equivalent capacitors, so its value is 2C. Okay, so this is the point y. Okay, now these two capacitors are in series, right? So in series we know that the formula 1 by C1 is equal to 1 by C1 plus 1 by C2, or we can write it as CS is equal to C1 C2 divided by C1 plus C2. Okay, so that is equal to, what is C1? C1 is C into C2 is 2C divided by C1 plus C2 means C plus 2C. Okay, now it will become 2C square divided by C plus 2C, 3C, here C cancel, so here you will get 2C divided by 3. Okay, so what is the value of C? C means A epsilon naught divided by D. Okay, so the answer is 2 by 3 A epsilon naught divided by D. Okay, so see now, next numerical is a system of two capacitors of capacitance 2 microcoulomb and 4 microcoulomb is connected in series across a potential difference of 6 volt. The electric charge and electric energy stored in the system are. Okay, so here what they are saying, they have given a two capacitors. Okay, they have given a two capacitors having the capacitance of 2 microfarad and 4 microfarad. Okay, so it's connected in series across a potential difference, so it is connected to the potential difference, so its value is 6 volt. Okay, so the electric charge and electric energy stored in the system are, we need to calculate the electric charge, that is Q, and electrical energy in terms of U. Okay, so this we know that if the two capacitors are in series, the formula becomes 1 by C is equal to 1 by C1 plus 1 divided by C2. Okay, so 1 by C is equal to 1 divided by, what is C1 value? C1 value is 2 microfarad plus 1 divided by, what is C2 value is 4 microfarad. Okay, so 1 by C is equal to here, so what it will become, 4 2s are 8 and cross multiply it, 4 1s are 4 plus 2 1s are 2. Okay, so here it will become 4 plus 2 is 6 divided by 8, and C becomes, so reciprocal of this one, so it will become 8 divided by 6 micro coulomb. Okay, not coulomb, so microfarad. Okay, now I need to calculate the Q value. So what is the Q value? So Q becomes C into V. Okay, Q becomes, so that's why I have got the C value. In order to calculate the Q, I want C. So similarly, in order to calculate the U is equal to half CV square. Okay, so here also I want to calculate the C value, that's why I applied the series formula. Okay, so what it will become now? So Q is equal to, what is C value? So C is 8 divided by 6 into, what is V? V is 6. Okay, so now 6 ones are 6, so it will become 8 micro coulomb. Okay, so 8 micro coulomb. And energy, so what is energy? U is equal to half into, what is C value? So C value we got 8 by 6 into V square. So V square means 6 into 6, so 6 into 6. Okay, so here, so how will you solve? 6 ones are 6. Okay, so 2 ones are 2 fours are 8. Okay, so remaining is 6 fours are 24. So 6 fours are 24 micro, as in it is micro joule. Okay, so the answer are, charge is 8 microcoulomb and the energy is 24 microcoulomb. Okay, so this is the required answer. Okay, so see now, next numerical is, two point charges A is equal to plus 3 nanocoulomb and B is equal to plus 1 nanocoulomb are placed at 5 centimeter apart in air. The work done to move a charge from B towards A by 1 centimeter is. Okay, so what they are given? They have given two charges. So what is two charges value? So first one value is, so I will consider this as A and this as B. So A value is plus 3 nanocoulomb and B value is plus 1 nanocoulomb are placed at, so the distance is 5 centimeter. Right, and in air the work done to move a charge from B towards A by 1 centimeter. Okay, so this one is 1 centimeter. So I will consider this R1. So R1 distance is 5 centimeter and R2 value. So what is R2 value? So R2 value I need to minus 5 minus 1. Okay, why? Because we are moving the B towards A by 1 centimeter and the left out value is 4 centimeter. This is R2 value. Okay, now we know that the work done is nothing but the change in the potential energy. Okay, the work done is nothing but the change in the potential energy. Now, so that is work done is equal to in potential energy final minus potential energy initial. Okay, now I need to calculate the potential energy final minus potential energy initial. Okay, so that is W is equal to, what is potential energy formula? So that is 1 by 4 pi epsilon naught. Here they have given the two charges, so that's why Q1 Q2 divided by RF means, so the final value, or otherwise I will write it as R2. Okay, so R2 minus initial is 1 by 4 pi epsilon naught Q1 Q2 divided by R1. Okay, from both the terms 1 by 4 pi epsilon naught Q1 and Q2 is common, right? So I will take it outside, 1 by 4 pi epsilon naught Q1 Q2 is common and the remaining is 1 divided by R2 minus 1 divided by R1. Okay, now substitute the values. So what is the 1 by 4 pi epsilon naught value? So we will get 9 into 10 to the power of 9 into Q1. What is Q1 value? We will mark it as this one as Q1 and this as Q2. So Q1 is So 3 into nano means 10 to the power of minus 9 coulomb multiplied by Q2. So what is Q2 value? 1 into 10 to the power of minus 9. So into 1 divided by what is R2? So R2 is 1 by 4 minus 1 divided by R1. So R1 is 5. Okay. So R1 is 5. Okay. Now simplify this one. So W is equal to here 9 3 is 27. Okay. So here 10 to the power of plus 9 and minus 9, it will get cancelled. Okay. So now, and the remaining is 27 into 10 to the power of minus 9. Okay. So within the bracket we have, so now simplify this one. Okay. So here they have given the centi value. So centimeter means, so we need to multiply it by 10 power minus 2. Okay. So 10 power minus 2, I will take it this centi value as, so 10 power minus 2, so it will become 100. Okay. So divided by 1 by 4 minus 1 divided by 5. Okay. So if we take 4 and 5 LCM, what you will get? You will get 4 and 5 only. 4 5 is so 20. Okay. So 4 5 is 20 is LCM. So 5 ones are 5 minus 4 ones are 4. Okay. So we'll get 5 minus 4 means 1, right? So we'll get 1 by 20. So its value is 1 divided by 20. Okay. So now simplify this one. So W is equal to 27 into 10 to the power of, here 100 means 10 to the power of 2, right? So here 10 to the power of minus 9 into 10 to the power of 2. So how much you will get? So 10 to the power of 9 minus 2 is 7, minus 7. Okay. So into 1 divided by 20. Okay. What is the 1 by 20 value? So 1 by 20 means 0.05. Okay. 1 by 20 means 0.05. So if you simplify this one, so 27 into 0.05 into 10 to the power of minus 7 joule means you will get, so W is equal to, you will get 1.35. Okay. 1.35 into 10 to the power of minus 7 joule. Okay. So this is the required solution. Okay. So see the next numerical, the minimum value of effective capacitance that can be obtained by combining the three capacitors of capacitance. So here they have given the three values, 1 picofarad, 2 picofarad and 4 picofarad. Okay. So you see, keep it in mind, the capacitance value will be minimum in case of series. Okay. So that's why I will connect all these capacitors value in series. Okay. If I connect all the capacitors value in series, I will get a minimum effective capacitance. Okay. So what is value they have given? 1, 2, 4 picofarad, right? All are in picofarad only. So I will put the answers in pico only. Okay. See, in series we know the formula 1 by C is equal to 1 by C1 plus 1 by C2. This is for the two capacitors. For the three capacitors it will become 1 divided by C3. Okay. So now simplify this one. 1 divided by what is C1? I will call this as C1 and this is C2, this is C3. Okay. So 1 by C1 value is 1 by 1 plus 1 divided by C2 is 2 plus 1 divided by 4. Okay. Now simplify these two terms, after that these two terms. So what you will get? So 2 ones are 2, LCM 2 plus 1. So we will get 3 by 2 plus 1 divided by 4. So what LCM will get? 4 2s are 8, 4 3s are 12 plus 2 1s are 2. Okay. So we will get 14 by 8. Okay. Divided by 2, 2 7s are 14, right? 2 7s are 14, 2 4s are 8. Okay. 2 7s are 14. So we will get 7 by 4 picofarad, but this is reciprocal. This is in the form of 1 by C. Okay. But if you take a reciprocal of this one, you will get C is equal to 4 by 7 picofarad. Okay. Answer is 4 by 7 picofarad. Okay. So see now, next numerical is a mass of 1 kg carrying a charge of 2 coulomb is accelerated through a potential of 1 volt. The velocity acquired by it is, okay. So here So what they are given? A mass of 1 kg. So mass is, so m is equal to 1 kg, okay, and having a charge. So charge value q is equal to 2 coulomb, and it is accelerated through a potential of 1 volt, okay. So potential value they have given v is equal to 1 volt, okay. So here I need to calculate what is the velocity acquired by it is. So here we need to calculate the velocity v is equal to question mark, okay. See now, so we know that potential in terms of work done is given by v is equal to w divided by q, okay. So w becomes potential into charge, okay. Now we know that kinetic energy work done is nothing but a change in the kinetic energy, okay. So work done is nothing but a change in kinetic energy. So that is w is equal to change in kinetic energy is given by half m v square, and v value is given by w is equal to v into q. So that is equal to half m v square, okay. Now cross multiply this one, so we will get 2vq is equal to m v square, okay. So here I need to calculate v square. So v square becomes 2vq divided by m, okay, and v becomes square root of 2vq divided by m, okay. Now substitute the values. So v is equal to square root of 2 into, so what is potential value? They have given 1 into charge value. So charge value they have given 2 divided by mass is 1, okay. So here you will get, so 2 2 is 4, root 4. So root 4 means its value is 2 meter per second, okay. So the answer is 2 meter per second. So hello everyone. See now next numerical is for the arrangement of capacitors as shown in the circuit. The effective capacitance between the A and B is, okay. So here they have given a circuit. Here I need to calculate what is the effective capacitance between the point A and point B, okay. See, this looks like very complicated circuits, but it's very simple only, okay. For simplicity I will take, so this point as C and this point as D, okay. See, if you have the all the capacitors value is same and you have 5 capacitors, obviously it is Wheatstone bridge only, okay. So you can easily guess it is Wheatstone bridge. Now I will reduce this complicated circuit in the form of Wheatstone bridge. So Wheatstone bridge, it looks like this, okay, and the middle of the circuit we will get another capacitors, okay. See now I will mark it as this point as A, and this is as B, and this as C, and this as D, okay. See, in between A and C we have one capacitor, right. So in between A and C we have one capacitor, and between C and B we have one capacitor, between C and B we have one capacitor, and between A and D we have one capacitor, between A and D we have one capacitor, and between D and B we have one capacitor, okay, and between C and B we have one capacitor, okay. So now the circuit becomes very simple, okay. All the values are 4 microfarad only, okay. So this is also 4, this is also 4, this is also 4, this 4, okay. See, for the condition of Wheatstone bridge is P by Q is equal to R by S. So then, so the middle value, so the middle capacitor value, it will become 0, okay. So this is the condition. So we will learn more about this in current electricity chapter, okay. Now see the figure. So these above circuits, these 4 microfarad and 4 microfarad are in series, okay. So in series we know the formula, Cs is equal to C1 C2 divided by C1 plus C2, okay. What is C1 C2? All are 4 only. So 4 into 4 divided by 4 plus 4, okay. So how much we will get? 4 4s are 16 divided by 8, okay. So 8 1s are 8 2s are 16, okay. So we will get 2 microfarad, okay. So I will call this as CS1, okay. Similarly, So if you calculate for the lower circuits, CS2 also became 2 microfarad only, right? Now again I will simplify this circuit. Okay, so how it will become? So now I have calculated this two capacitors value. It is 2 microfarad and lower side is also 2 microfarad. Okay, now these capacitors are in parallel. So in parallel we know that the formula Cp is equal to C1 plus C2. Okay, so you will get 2 plus 2, so that is equal to 4 microfarad. Okay, so the answer is 4 microfarad. See the next question. The work done to move a charge on the equipotential surface. Okay, see now we know that equipotential surface. What is the equipotential surface? The potential remains same at all the points. It is called equipotential surfaces. Okay, see, suppose if I consider this L as 5 volt, means at all the points is 5 volt only. Okay, so suppose if I consider any charge over here, so if I want to move the charge, I don't need any work done. Why? Because the potential is same and the work done also becomes same. Okay, so if you take a potential difference, you will get 5 minus 5, so it is 0 only. Okay, so see now next numerical is two capacitors of 3 microfarad and 6 microfarad are connected in series and the potential difference is 900 volt is applied across the combination. Then they are disconnected and the reconnected in parallel. The potential difference across the combination is, okay, they have given the option 0, 100, 200 and 400. Okay, so what they have given? They have given the two capacitors. So its value is 3 microfarad, another one is 6 microfarad are connected in series and it has a potential difference of 900 volt. Okay, and it is applied across the combination and they are disconnected and are connected across the parallel. Now we need to calculate the what is the potential difference. Okay, potential difference, so V is equal to question mark. Okay, so here this is, so 3 microfarad and this is 6 microfarad. Okay, see, for series combination we know the formula 1 by Cs is equal to 1 by C1 plus 1 by C2. Okay, I will consider C1 as this one and this C2 as this one. So what you will get? 1 by Cs is equal to 1 divided by 3 plus 1 divided by C2 is 6. Okay, so if you simplify this one, so 6 3 is 18, 6 1 is 6 plus 3. Okay, you will get 9 by 18, 9 1 is 9 2 is, so Cs value is 1 by 2. Sorry, 1 by Cs value is 1 by 2 and Cs value, because if you take a reciprocal you will get 2 microfarad. Okay, and what is the Q value? So Q value will get Q is equal to C into V, right? So what is Q? What is C? C is 2 into V is 900. So you will get, so 9 2 is 1800 microcoulomb. Okay, so this is the charge value for the single capacitor. Okay, so this is the charge value for the single capacitor. Here we have the two capacitors. For the two capacitors, so it will become, Q becomes, so 2 times of 1800, so that is 18 to the 36 microcoulomb. Okay, so this is Q dash. I will consider this as Q dash. Okay, now we need to calculate the potential. So what is the potential? So potential becomes, so we know that C is equal to Q divided by V and V becomes Q divided by C. Okay, so what is the Q value? So Q value is 3600, so divided by, so C. Okay, so what is the C value we got? See, C value means the combination of these two. Okay, so what is the combination? That is 3 plus 6, so that is equal to 3600 divided by 9. So here 9 ones are 9 fours are 36, so we'll get 400 volt. Okay, so 400 volt is the required solution. So see now, Next question is, two metal plates are separated by 2 centimeter. The potential of the plates are minus 10 volt and 30 volt. The electric field between the two plates is, okay. So what they are given? They have given a metal plates and are separated by 2 centimeter. The separation means D value, that is 2 centimeter. Write it in the SI units. So 2 into what is centi value, 10 to the power minus 2 meter, okay. The potential of the plates are, here they have given the two potentials. That's why I will take a potential difference, that is delta V. See, delta V, always we need to minus higher potential minus lower potential, okay. So that is equal to, what is the V2 value? So that is 30 minus 10 volt, okay. So that is equal to delta V is equal to 30 minus into minus plus, so we will get 40 volt, okay. The electric field between the two plates. So here you need to calculate electric field, E is equal to question mark, okay. See, electric field is given the formula. Electric field is negative times of potential gradient, okay. So that's why E is equal to minus dV by dx, okay. So here, so that is E is equal to, I will take V by, so x, say x is nothing but the separation or the D value, that is D, okay. So that is equal to, what is V value? So V is 2 into 10 to the power of minus 2 divided by, sorry, V is 40 volt. So V is 40 volt divided by D value is 2 into 10 to the power of minus 2. Here 2 ones are 2 2s are, okay. So here 20 into, here 10 power minus 2, if you go to the numerator it will become 100. So we will get 2000 volt, okay. So the answer is 2000 volt per meter, okay. So it is volt per meter. See the next question. The equivalent capacitance between A and B is, okay. So here they have given a circuit. Here I need to calculate what is the equivalent capacitance between the A and B, okay. See, if you observe the circuit, 100 picofarad, 100 picofarad are in series, okay. So in series we know the formula, 1 by Cs is equal to 1 by C1 plus 1 by C2, okay. So that is equal to 1 by 100 plus 1 by 100. So we will get 2 divided by 100. So that is 2 ones are 250s are. So CS value becomes 50 picofarad, okay. So finally, so these two values we will get 50 picofarad. So now this circuit becomes like this, okay. This is 50 picofarad, this is 50 picofarad, okay, and this is 50 picofarad, and this is the value of A and this is the value of B, okay. Now these two capacitors are in parallel. In parallel we know that the formula Cp is equal to, so Cp is equal to C1 plus C2. So if I consider this one as C1 and C2, it will become 100, okay. So now we will get 50 plus 50, so that is equal to 100 picofarad, okay. Now again this circuit becomes like this, okay. So this is 100 picofarad and this is 50 picofarad, okay. So this is point A and point B, okay. See, if you see the figure, so it looks like parallel but actually it is in series, okay. So this diagram can be written as like this, okay. So this is one capacitor, this is another capacitor, and it is connected to the potential A and B, okay. So it is 100 picofarad and 50 picofarad, okay. Again we need to apply the series formula. So I will apply another formula, Cs is equal to C1 C2 divided by C1 plus C2. So that is equal to, what is C1 and C2? 100 into 50 divided by 100 plus 50, okay. So how much you will get? So 100 plus 50, 150, okay, and 100 into 50. So 100 into 50 will get 1500. So if you divide this one, so we will get 100 divided by 3 picofarad, okay.
So this is the required answer.